Algebra 1 Common Core, Unit 3, Section 2, Difference of Two Squares, abbreviated to DOTS. So, in the last video, we learned about factoring with a GCF, a greatest common factor. Difference of two squares is another factoring method, but it's a factoring method that could only be done on binomials, but not only that, specific binomials. Difference of two squares is exactly what it is in the in the title, that it needs to be a binomial with a difference. So you'll see for all of these problems, all these binomials, they all have subtraction signs in the middle because they're a difference of two, that's why they're called binomials, squares. So they're a difference, a subtraction of two squares. X squared is square, and you'll see that the numbers are square, like 81 is square. Here we have 144 is square, 4 is square, 9 is square, 1 is square, 36, 4, 49, 25. Remember the square numbers that we're used to from simplifying the radicals. Real quick, that list, let's generate that list. That's 1, 4, 9, 16, 25. Those are the first 5 squares. And remember, that comes from 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. And that's another way of saying 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. 6 times 6 is 36. 7 squared is 49. 8 squared is 81. Hold on, I skipped one there. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And then 15 squared is 225. I'll be honest with you, I'm not great with those last three. I'm pretty sure that those are correct. But you don't have to have these memorized this far. You should know the squares pretty automatically, 1 through 10, definitely, 1 to 100. You should know these square numbers pretty easily. After that, it may take some memory. I mean, these 11 and 12 is what I learned when I was, in high school. 13, 14, 15, I've kind of picked up by memory along the way. But anyway, those are our squares. So, anytime we're working with a difference of two squares, it has to be one of those numbers. It has to be the coefficient or the constant. So if you have a difference of two things that aren't squares, like if we see x squared minus 10, that's not a difference of two squares, and we cannot use dots factoring, because 10's not on this list of square numbers. So that's not going to work. If you see x squared plus 16, well, 16's on the list, but it doesn't work because of the plus. It has to be a difference, and difference means subtraction of two squares. As far as the variables go, you see that x squared is obviously squared, and we see a lot of those. But there's other variables, exponents as squared. X to the 4th, y to the 6th. Those are considered square as well. Because if you remember, a square comes from something times itself. Like, 7 times 7 is 49. Well, x to the 5th times x to the 5th equals x to the 10th. Remember, when we multiply, we add the exponents. That means that x to the 10th would be considered a square expression because it comes from something times itself. So basically what we're trying to say here is that any variable that has an even exponent, so x to any even number, is considered a square. These are your square numbers, but x to any even exponent is also considered a square. And so we'll get to that in a little bit here. So there's a couple of examples, a couple other notes. The result of factoring is the product of two binomials. The term in each of the factors are the square root of the terms, original expressions. One is with a sum, one is with a difference. So let me show you, for example. A squared minus b squared. It's going to factor to a plus b, a minus b. Now, a and b are the square roots of a squared and b squared. And we get one with a plus, one with a minus. X squared minus 9. Well, the square root of x squared is, of course, x. The square root of 9 is 3. And one of our binomials gets a plus, one of them gets a minus. A few more. Here's 4x squared minus 25. The square root of 4x squared is 2x, and 2x, right? Square root of 4 is 2. X squared of x squared is x. Square root of 25 is 5 and 5. One with plus, one with minus. And this is really just the pattern that you're going to see for all of these. So this is actually a pretty quick thing once you see it. When it comes to the higher exponent stuff, all you can do is cut it in half. So like we saw x squared comes just to be x and x. Well, the exponent 2 divided by 2 is 1. And so that's what we'll see here, that when I have 9x to the 4th, well, the square root of 9, of course, is 3. But the square root of x to the 4th, I take my exponent 4 and I cut it in half to x squared, x squared. The 4y to the 6th, I'm going to get 1 with a plus, 1 with a minus. And then the 6th, I divide it by 2 to get y to the 3rd, y to the 3rd. So exponents get cut in half. And regular numbers, like coefficients and constants, we do the square root of them, because they're square numbers. And you're always going to have a 1 plus 1 minus, because if we were to distribute these things, remember, factoring is just reverse distribution. Like this x plus 3, x minus 3. If I were to distribute this, x times x, I'd get x squared. X times negative 3 is negative 3x. 3 times x is positive 3x. Now those two terms in the middle are going to cancel out. That's one reason why we need different signs, is so that the middle terms cancel out. That's why we don't have trinomials here. They're binomials. But the other term is, remember, it's a difference. It always needs to be a minus something. And that minus something comes from a positive times a negative is negative. So that's why we're always going to get different signs. And then these middle terms would cancel out, and we're back to where we are here. So you could always distribute these or FOIL them, if you know the term FOIL, to get back to the original. You could distribute them. All right, let's try a couple fresh examples here. So x squared minus 25. Well, we're just thinking, what is the square root of these expressions? And we're going to do one with a plus sign and one with a minus sign. The square root of x squared is x, and the square root of 25 is 5. So it's x plus 5x minus 5. That's it. X squared minus 81, that's going to be x plus 9, x minus 9. Because the square root of x squared is x, square root of 81 is 9. 1 plus 1 minus. Now, it doesn't matter which one goes first. If you want to do x minus 9 first and x plus 9 second. I tend to always put plus first just because that's how I do it, but that's not necessarily right. Because remember, these are two things being multiplied. And multiplication follows the commutative property where the order doesn't matter. X squared minus 144. Well, the square root here. Uh-oh. Having problems. Sorry, hold on one second. Okay, sorry about that. Fixed little technical problems there. But all right, back to x squared minus 144. So the square root of x squared, I think we've got at this point, is x, and we're going to have 1 plus 1 minus. The square root of 144, and if you don't remember, you could always type in the square root in your calculator, but it works out, in this case, to be 12. Now, some of these, these are very basic. This 1 minus x squared is something that trips up a lot of students sometimes. They want to make it x plus 1, x minus 1. But the issue is the order. See how for all of these, x squared was, the first term in the expression? And that's why x is the first term in all of the factors. Well, if x squared is the second term, it's got to go in the back. And so you keep the order. And sometimes people forget about 1 in general. They forget that 1 is a square number, but the square root of 1 is 1. 1 plus 1 minus, and the square root of x squared is x. Now, is this the same thing as x plus 1? Yes, it is, but is this the same thing as x minus 1? No, it's not. So you want to keep whatever order there is in the original problem. So if x squared is in the front, then you keep the variable in the front. If x squared is in the back, then you keep x in the back. 4x squared minus 9. Did we have this? Oh, it's 4x squared minus 25, but it's pretty much the same thing. The only difference is we're throwing a number in front of x squared, as opposed to these, but it's still a square number from this list. So the square root of 4x squared is 2x, and the square root of 9 is 3. And then I'll have a 2x minus 3. Over here we'll have the square root of 36 and 49x squared. That's going to be 6 plus 7x, 6 minus 7x. The square root of 36 is 6. The square root of 49 is 7. The square root of x squared is x. All right, this last row just, tries to make it challenging because it's got larger exponents than 2. But again, it's simple. You just simply cut them in half. So x to the 10th is going to become x to the 5th. And then the square root of 121 is 11. So x to the 5th plus 11 and x to the 5th minus 11. So it's not really any harder. You just cut the exponent in half. For this middle one, 25x to the 4th. Well, that's going to be 5x to the 2nd plus something. 5x to the 2nd minus something. Then something comes from the square root of 64y to the 6th. Well, the square root of 64 is 8. And the square root of y to the 6th, we just cut that exponent in half, y third. And the last one. So there's no numbers in here, just letters. That's okay. The square root of a to the 8th, b to the 6th. Well, it's going to be a to the 4th, b to the 3rd. Right, we're just cutting our exponents in half. 1 plus, 1 minus. And then square root of c to the 4th, d to the 2nd is going to be c squared d. You can write d to the first if you want. C squared d. That's it. So it's really just a pattern. And when you know you're factoring a difference of two squares, I think it's simple. But what gets a little complicated is you got to recognize it. You know, what separates this from the GCF factoring that we were doing, you know, in the previous video? Well, the biggest difference is that there is no greatest common factor. If you take a look at, you know, 9x to the 4th, what, you know, they don't both have x. They don't both have y. There is no number you could divide 9 and 4 by. So there is no greatest common factor, and that's important. That you should always look for that GCF factoring first, like in that last video. But when that's not there, then you start looking for the other types of factoring. And if you see it's two terms with a minus sign between them, you know, if it's a difference of two things and those two things are both square terms, then you know you're working with a difference of two squares factoring. And you can follow the procedure from there. See ya.